Homework.
The groups you're told to write.
Oh, that. Okay. Fine. Yeah. So all of you completed this? Yes or no? Tell me.
Yes, sir, I completed.
You completed? Okay. This part. Rishita?
Yes, sir.
Completed. What about you, Khodeja? Khodeja Bashir, did you complete this homework?
Yes, sir.
Okay. So no one sent me, but okay. After the class, maybe send it to me, okay? अच्छा, एक अच्छी खबर आप लोग के लिए है. Those who have not done some basic concepts, Jabi Khan is no student for someone else. One good news is that from Saturday we are going to start the extra classes on some basic concepts of chemistry. That is chapter number 1. Okay. Those who have not done the chapter with me, they can do it with me. August, this is Thursday. So the timings of that classes will be some basic concepts. Don't write this, okay? This is the topic for extra classes, okay? The backup class, I mean, good word will be backup class, backup problem. Backup class, the timing will be 12:30 p.m. Okay, this will be noon, IST, Indian Standard Time. This will correspond to 10 a.m. ASA, and I think 11 a.m. UAE. Is that right? Rishita, 11 a.m. only, no?
Yes, sir.
Okay. So all of you are a part of a WhatsApp group, right? Yes or no?
Yes.
What about you girls? Khadija, Khodeja, and Aqib?
Yes.
Aqib,
Yes,
you're
sir.
on a group, right? Yeah, okay, fine.
Sir, can I also join extra classes?
Yeah, sure. Anyone can join.
Okay, sir.
Okay. Those who have done with me, those who have not done with me, all of them can join them. Fine. So let us continue with our some basic concept. Classification of elements and periodicity. So in the last class, I just wrote the properties that we are going to study, right? So we will start with effective nuclear charge. So please write the topic. Write topic, effective nuclear charge, number 1. Effective nuclear charge. This is denoted by Z effective. Z effective. Okay. Now, let us first of all understand this concept of effective nuclear charge, because this is one of the most important concepts in the periodic table. Okay. Now, all the other properties that we are going to learn, they are going to be depending on this particular effective nuclear charge. So if you understand effective nuclear charge, then it will be very easy for you to understand the rest of the properties. Now, what is effective nuclear charge? Please, I am taking the example of sodium atom. Now, sodium atom, it has the atomic number of 11. That means the nucleus which is positively charged, it will have 11 protons. Correct, guys? Yes or no? Please tell me. There will be 11 protons, and first shell, second shell, and third shell. Okay. So in the first shell, I will have 2 electrons. Right. Then in the second shell, I will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Right. So 8 plus 2, 10. And then I will have an electron in the outermost shell. So I have shell number 1, shell number 2, and shell number 3. So what do you think? Which electron will be attracted? They will experience the largest attraction. The shell number 1, 2, or 3. Which electron will experience the largest pull from the nucleus, the largest attraction from the nucleus? Tell me, guys. Which electron?
Shell number 2.
The first shell, second shell, or third shell? Which
Second.
electrons? Second. Why second?
Because it has the most electrons.
Okay, so let us now try to argue with yourself regarding which of the following is going to get more attraction. Okay, so positive charge, and you have a negative charge here, and positive charge, and you have a negative charge here. Tell me, which electron will get A case or B case? Where do you think there will be more attraction? Where do you think there will be more attraction? Yes, Rishita?
The A case.
A case. Now argue. Now, please understand that this electron is not one entity. Okay, this electron is not one entity. Each individual electron will be experiencing its own attraction, right? That is why the largest attraction will be on what? On the first shell. Can all of you understand that? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Right? The first electron. Now, the least attraction will be viewed on the third shell, right? Yes or no? Correct. This electron will be experiencing the least attraction. Rishita, Puteja, Khadija, all of you clear? This will be experiencing the least. Correct. Now, this is not, that means if it is experiencing less nuclear charge, that means it is affecting, that means it is experiencing less attraction. It is experiencing less attraction. That means it is not experiencing pull of the 11 protons. Is that right? Yes or no? Please tell me. Correct, na? If it was experiencing the total pull, then it would have been experiencing the pull of complete 11 protons. But as we know that it is experiencing the least, that means it is experiencing less nuclear charge. It is experiencing less attraction, less pull towards the nucleus. That is why it is not experiencing all the pull which is given by the 11 protons. All of you understood that? Yes or no? Please tell me. Correct?
Yes, sir.
Now, this is only happening because of the anyone having any doubt, please let me know. This is only having because of these inertial orbitals. Now, you can imagine in this way. When you are in a classroom, we have your first row, second row, third row, fourth row, and so on, right? And the teacher is teaching here. You have a board and all, right? The teacher is teaching here. So obviously, the people who are sitting in the last bench, they will be not as focused as the first one. But let us imagine that we don't have these benches. Then the last one will be as focused, right? Similarly, here also what is happening? Due to the inertial electrons, the outermost electron is not experiencing complete nuclear charge. It is not experiencing complete nuclear charge. So these inertial orbitals are acting as shield. They're acting as barrier or shield, and that is known as screening effect. That is known as what? Screening effect. So for this, first of all, we will write screening effect, and then we will look on to the next question. Please write screening effect. Shielding or screening. Shielding or screening. Okay. So what is shielding or screening? Please write the reduction in nuclear charge due to inertial electrons is called shielding or screening. Okay. So the outermost electron, it does not experience the complete nuclear charge that is given by Z. It is rather experiencing some nuclear charge that is known as Z effective. Effectively, how much it is experiencing? So it is experiencing Z minus sigma, and this sigma is shielding. This sigma is shielding, right? Next point. the reduced nuclear charge is called effective nuclear charge. Z effective. Okay. Now this Z effective is completely depending on shielding. So we'll understand shielding and then we can talk about the Z effective also. Okay. So let us talk about shielding. The order of shielding, if I talk about order of shielding, is right. Order of shielding. Now we know that the S subshell, it is spherical in shape, right? Then we have the P subshell, which is having a dumbbell shape, and then we have the D orbital, which is having a double dumbbell shape. D orbital, it has double dumbbell shape, right? And then F is complicated, it's very complex. It will be having, obviously, we know this from the previous chapter. Here we have 1 lobe, 2 lobe, 4 lobe, and then 1 double 2, double 4, double 8 loops. It will be having 8 loops. So the electrons will be getting diffused. That means it will be in a very larger area. S is very constricted. As you can see, it's a very small area. But if you look at the p orbital, it is going everywhere here and there. So obviously S is very concentrated. That is why S subshell will be shielding the most, followed by P, then D, and then F. This is P, this is D, and then for F, the shielding is lowest. Okay, so order of shielding, number 1 point, which orbital or which subshell shields the most? S subshell shields the most, then P, then D, and then F. Why is that happening? Because S is less diffused. Okay, S is less diffused, very constricted. It is having only 1 lobe. Electrons are constricted in one area, not a very large area. If you look at P, electrons are dancing from here to here. In D, it is dancing from here to here and here to here. In F, the case will be even more worse. After this, right, next point. Right here, from top to bottom in a group, the Z effective is constant. Z effective is constant. So why is that happening? It is because the proton number, the protons increases, as well as the shell number increases. Okay, so what is happening? The proton is also increasing, right? And the shell number is also increasing. So effectively, the effective nuclear charge, it remains constant. Right, next point. In a period, as atomic number increases, electrons are filled in same shell. But in same shell, but in different subshells. But in different subshells. And the shielding of subshells follow the order. What order it follows? S most, then P, and then D, and then F. That is why what happens, please see. Along a period, shielding decreases. and Z effective. Therefore, what happens? Z effective increases, right? Therefore, Z effective increases. And as we know, Z is equal to what? Sorry, Z effective. It is equal to Z minus sigma. So if this sigma will decrease, this negative thing will decrease. So obviously, this whole thing will become greater. All of you got this? Yes or no? Please tell me. Now you are very late today.
Sorry, sir, network problem.
Is everyone done? Yes or no? Please tell me.
Yes, sir.
Everyone done? No. So once we are done with this, you can write one more point. Main thing that you have to remember are these 2 points. Okay, in a period, atomic number, first of all, top to bottom, it is constant. In a group, it is going to be constant. It is constant. This is a result that you have to remember. And then you have to remember along a period, shielding decreases and Z effective increases. Okay. So pull from the nucleus will increase as we go along a period. Now you can also write Z effective for ions of same element. So for this Z effective, it is directly proportional to positive charge. And it is inversely proportional to negative charge. Obviously, if we have positive charge, then more pull. So more Z effective nuclear charge increases. Negative charge, that means we are adding more electrons. So that more electron is going to be shielded more off. Okay. Now, if we have different, if you're having different, then you have to look at the charge. So once again, you have to look at the charge. Mainly, the point is that okay, more charge, that means there will be more charge, then there will be more Z effective of same element, and you can write isoelectronic species. Okay, isoelectronic species. But main point that you have to remember is for group, it is constant. For period, it increases. Z effective increases along the period, and it is constant in a group. The second part, that is atomic radius. Please, what is atomic radius? What is atomic radius? First of all, it is distance between the center of the distance between the center of nucleus and the outermost electron. What it is? Atomic radius, distance between center of nucleus and the outermost electron. And the outermost electron. Now, accurately measuring the atomic radius will be very difficult. Why? First of all, isolation of one atom. How will you take one atom? That's a bigger problem. And how to have only one atom and then measure it. Next thing is that atom does not have well-defined boundary. Why? Because electron have wave nature. And how can you restrict a wave? Okay. How can you restrict the wave? That is why these are the two main problems of measuring the atomic radius. So right here, first point here, this is the definition, distance between center of nucleus and the outermost electron. Next, you will write the difficulty in measurement. Please write, it is very difficult measure atomic radius. Atomic radius, because number one, isolation of an atom is difficult, is very difficult. Second point, atom does not have well-defined boundary. Well-defined boundary. Atom does not have well-defined boundary. Why? Because the electron has wave nature. And probability of finding electron is 0 at infinity. What is the meaning of this? Please understand. I have an atom here, a nucleus here, then we have atom. So till here I can find atom. There is 99% probability that you will find the electron in this particular, under this particular radius. But even if I go here, there is also 0.000001% chance that you can find the electron here. If I go here, here also there's 0.0001% chance to find the electron. So what should I take as the outermost electron? How should I take that? How should I define a boundary for an atom if there is a 0.001% chance of finding electron? Okay, so this problem, second problem, will only be there if we are able to overcome the first problem, the isolation of atom. First of all, that is also difficult. Even if we we cannot isolate an atom. Even let us suppose theoretically we did it also. Then how can we define the boundary of an atom when the electron has wave nature and the if the electron can be present here 0.00001% chance. So how can I say that, okay, fine, it will not be found here, there it will also be found there. So where is the probability of finding electron 0? That will be the boundary. Let us suppose we have an atom here. We have an atom here like this, and the probability of finding electron is 0 here. After this, you will not find the electron. But what is this position? Infinity. Who knows infinity? No one knows infinity. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
तो क्या मतलब एटॉमिक रेडियस नहीं पढ़ना? पढ़ना है. पढ़ना तो है. So how do we measure? We will approximate. So please write. Based on the type of chemical bond, write with me. Based on the type of chemical bond, atomic radius can be approximated. Atomic radius AR. Atomic radius can be approximated by following methods. By following methods. Number one, if we have a covalent radius. You guys in 10th standard have heard about covalent bond, right? Yes or no?
Yes, sir.
Okay, so if you have covalent bond, we will get covalent radius from that. Then we have ionic radius. You have also learned about ionic bond, yes or no?
Yes, sir.
Anji, right? You have heard about ionic bond, right? Third is
Yes.
metallic radius. So for metal, we will use metallic radius. And the fourth part, there are some atoms, भले ही उनको नोबल कह लीजिए आप, लेकिन होते तो बदमाश, किसी के साथ रिएक्ट ही नहीं करते. So for that, we are going to take van der Waals radius. Van der Waal was a guy. You will hear this till 12th standard. Van der Waals radius. Van der Waals radius. Okay. So first of all, we will look at covalent radius. Right, the topic covalent radius. What is covalent radius? It's very easy. This right. Covalent radius, CRIRMRV. CR. So covalent radius, this is equal to distance between nuclei of covalently bonded atoms. Distance between, ऐसे लिख दीजिए, covalent bond length of covalent bond, okay, divided by, sir, how, sir? See here. When we have covalent bond, in that case, we will be having sharing of electrons. When we will be having sharing of electrons, then we will have two atoms like this overlapped with each other, and you will have a nucleus here. The other nucleus will be here, a nucleus here, and the other nucleus here. The distance between these two nuclei is known as the bond length. The distance between these two nuclei is known as the bond length. And when I half this, I will get the covalent radius. Okay, so this is approximation. You can see there is some, sir, ये तो पूरा atom का नहीं बता रहा, आधा atom हो जा रहा है यहाँ पे. हाँ, obviously approximations. No, that is why these are approximation. All of you understood this? Please tell me.
So can you explain it again?
Oh. So covalent bond is formed by sharing of electrons, right? Yes or no? You know this? Or this is new
Yes, sir.
information? You know it, right? So if we are sharing electrons, electrons are not going anywhere. So let us suppose one electron is here and the other electron is here, right? And this is the nuclei. Oh, this is nuclei, okay? Center. What we will do, we will measure the distance from here to here. This will be bond length. This will be bond length of the covalent radius. So because you have atom A and then bond and atom A. So this distance, this bond length divided by 2 will give you the atomic radius of this atom, and this half will give you the atomic radius of this atom. Got it, Rishita?
Yes, sir.
So if I will write molecules and then bond length, then you can write the radius of atom also, right? So let us suppose you have molecules. Bond length and the radius of atom. Atomic radius, atomic radius. So in molecule, let us suppose we have number 1, hydrogen. Number 2, what do I remember else? Chlorine, I think I remember, and bromine. So bond length, this is 74, 198, I suppose, and 228. All of these will be in picometers. Okay. So for 74, what will be the atomic radius then? If the bond length is 74, atomic radius will be half of it, na? Half कीजिए कितना जाएगा? 74 half?
37.
37, है ना? And 198 half will be 198 half?
99.
99. 228, 114. Got this? ऐसा कुछ आएगा नहीं, फिर भी एक बार अंदाजा हो गया आपको कि होता क्या है ना? सवाल आ जाए तो आज आएगा नहीं, लेकिन इस तरह का सवाल. They will just ask you what is the definition, then you will write covalent bond length divided by 2. That's it. This is the definition. This is definition only. Right, next, metallic radius. This is the first. Right, second one, metallic radius. If we look at metals, then metal have a peculiar shape. What shape it has and why it is peculiar, please see. So the metallic atoms, they are not bonded exactly, but rather they are just situated adjacent to each other. They'll be situated adjacent to each other like this. Okay, now so this is a metal. Just a second, guys. Okay. So in metallic radius, what we are going to do is we'll take the nuclei of atom from here and then from till here. These are the two nuclei. And once we get the metallic bond length, then what we are going to do? We are going to half it once again. This is the metallic bond length, right? And we are going to half it. So here we have nuclei and here we have nuclei. Simple. So what is this? This is 1/2 of. How do we define this? Please write. 1/2 of distance between two adjacent atoms. Wait a second. In metallic lattice. Lattice का मतलब होता है 1 point, 2 point, 3 point. All of these are making a lattice. So this complete thing is known as lattice. So the metallic radius will be equal to metallic bond divided by 2. Now look at the way we are measuring the covalent radius. We are measuring the covalent bond or the covalent radius and the metallic radius. Tell me which one will be larger? Which will be larger, covalent or metallic? Which will be larger, covalent or metallic? No idea. Metallic. As you can see, overlapping of orbitals or the overlapping of atoms is not happening here, right? So these metallic radius, they are one atom and then next atom. Here we are having mixing, or we can say overlapping also. That is why this will be metallic radius will be larger. So right, as there is no overlapping of orbitals, as metallic radius is greater than covalent radius. Is everyone done? Yes or no? Please tell me.
Yes, sir. Finish.
Right, next, van der Waals radius. Van der Waals radius. Now, van der Waals radius is for the atoms which are not having any bond within them, right? So they will be like this. Now, helium, if I'm going to look at the helium gas will be like this. Someone here, someone there, right? So how are we going to measure the van der Waals radius? So what we will see, we will first of all see the nearest atoms. Okay. So nearest atom, two adjacent atoms. So I'm deleting these part. Let us suppose that these are the nearest atoms. So we will have the nuclei here maybe, and maybe here. So we are going to now join them. Okay, now we are going to join them and we will call this distance as D. Call this distance as D. Okay, so the van der Waals radius will be equal to D by 2. So how can I write this? Please write 1/2 of internuclear distance between the nuclei of two adjacent atoms of a substance. Two atoms of a substance belonging to two neighboring molecules in solid state. It's called van der Waal radius. Now, so obviously you can see that van der Waal radius will be even larger, right? Van der Waal radius will be even larger. We can write here van der Waal radius is largest, followed by metallic radius, followed by covalent radius. Done everyone? Yes, no, please tell me.
Yes.
Anyone still writing? No, na?
No, sir.
No.
Right, next. The ionic radius. Fourth part, please write. Now, we very easily told ionic radius, but I think all of you guys must know that there are two different types of ions, right? There is cation and we have anion. Cation and anion. Right, guys? This will be tell me.
Yes, sir.
So in an ionic radius, please, we have ion, which are of two types. We have anions. We have anions. So anion will be formed if I have, let us suppose A, an atom A, and this atom A, we are adding to it n number of electrons. So it will get A with n negative charge. For cations, I have atom A, and from atom A, I am removing n electrons. So it will get n positive charge, and n electrons will be removed. It is away from the atom now. Okay, so please don't understand this is getting added. No, so n electrons has been removed. This is initial, this is final. Now, if you see here, we can say that atom A, अच्छा atom A को ना parent बोलते थे, ठीक है? Let us call this as atom A as parent. Okay, this is parent. If I compare the parent and the cation and anion, so obviously in the case of anion, A will be smaller in size than An negative. Why is that? Because anion is larger than the parent atom. Why is that? Because we have more electron. But the nucleus is having the same number of proton, and we are keep on increasing the electron. So how much electron can the nucleus pull? It cannot pull more, right? So in parent, let us suppose we are having 10 proton and 10 electrons. then the protons can easily pull. But if I am adding more electrons, then the protons will not be able to pull those extra electrons as effectively. That is why we'll say anion is larger than cation. Now, in the case of sorry, cation लिख दिया ना, my bad, is larger than parent. Cation से तो हो गई, parent से भी larger. In the case of cation, since we have removed electrons, it will be easier for the. It will be easier for what? It will be easier for the protons to pull the electrons, remaining electrons, because we have removed some electrons. It will be easier for them to pull less number of electrons. So I can write cation is smaller than parent. Cation is smaller than parent, right? Now from here we can write the largest size will be for anion. I am looking at one same atom. Anion will be having the largest size, then the parent, and then the cation. Also, another thing we can write, ionic radius for ionic radius we can write what? We can write that it is directly proportional to the ionic radius will be larger if we have more negative charge, directly proportional to the negative charge, and it is inversely proportional to the positive charge. Is that right? Yes or no? Please tell me.
Yes, sir.
Okay. Now, next point. Ionic radius increases as we go down the group because the shell number increases. So the electrons are further away, and further away. इसलिए यहाँ पे ब्रैकेट में लिख लीजिएगा फॉर आइसो इलेक्ट्रॉनिक स्पीशीज. Isoelectronic species are which are having same number of electrons. They are having same number of electrons. Okay. So this is completely about ionic radius. Now we are going to write some remarks regarding atomic radius. Okay. So please write trends in atomics. This is for.
Also,
Tell me.
the last sentence.
Yeah. Please write. Please.
Yes, sir, I'm good. I'm done.
Everyone done?
Yes, sir.
Everyone done?
Yes, sir.
Ionic radius has grown. Now please write trends in atomic radius. So number one, atomic radius increases as we go down the group. Because shell number increases. No, same thing. Secondly, atomic radius decreases as we go left to right. In a period, because first of all, if you go along a period, then you know what is going to happen along a period. If you go along a period, then what is going to happen? The Z effective is increased because the Z effective increases. है ना? So if Z effective is increasing, so nucleus will pull more. Yes or no? The nucleus can pull more. Correct, guys? More positive charge
Yes,
means
sir.
more pull.
Yes, sir.
If it is pulling more, that means what? The electrons will be nearer. Nearer means atomic radius will be small. है ना? So the size of atom will shrink because the Z effective increases and the electrons are added in same shells, and shell is also not increasing in same shell. Got this presentation, me? All of you got this? Anji. Understood, na?
Yes.
These 2 points. Okay. Now you will write a note here. So what is happening? This is now the conclusion you have to remember. Okay. Conclusion क्या है यहाँ पे? Atomic radius. If you look at group में क्या होता है? Increase करता है ना, top to bottom. In a period, it decreases. This is from top to bottom. And period में decrease करता है left to right. ठीक है, तो इसको ध्यान रखना है बिल्कुल. You have to remember this conclusion. समझने वाली बात तो है ही, जो समझ लिया आपने. अब ये चीज आपको याद रखनी है ना, जैसे 2 2 जा 4 होता है, याद भी है आपको और आपने समझा हुआ भी है. 2 को 2 बार लिखेंगे तो 4 हो जाएगा, है ना? इसी तरह से. Now write a note. For noble gases, only their van der Waal radius exists. As they don't form. As they don't form compounds. As they don't form compounds. Therefore, along the period, respective noble gases, respective इज्जत नहीं, मतलब उस पीरियड का नोबल गैस, respective, ऐसा नहीं 15 अगस्त आ रहा है, स्पीच याद कर रहे होंगे. अच्छा, आप लोग की तो छुट्टी रहती है ना 15 अगस्त, क्या है स्पीच बोलिएगा. Respective noble gases has the largest atomic radius, as the largest atomic radius, है ना. अच्छा, ऐसा सी आप बोले सर पीरियड में तो डिक्रीज करता और नोबल गैस सबसे आखिरी में आता है, उसका तो सबसे कम होना चाहिए. यस, ट्रू, correctly true. That period may, if I am going from left to right along the period, and in the last we are going to get the noble gas, so this noble gas should have the least atomic radius. I will say yes, but the data that we have is only about the van der Waal radius, and we have seen that van der Waal radius is what it is, largest. So even though it may be small, but we cannot approximate. The data that we have is what it is saying, that van der Waal radius will be highest, and for noble gases I can only approximate with using van der Waal radius. That is why the noble gas will have the largest, they will have the largest atomic radius in the respective period. So if I talk about the different periods in the periodic table and their noble gases, or rather I would say the largest atom, so in the group 1 you will have helium as the largest. In group 2 you will have neon as the largest atom. 3 may you will have argon, and so on. Okay, but if you see, I mean, after helium, you will, sorry, after helium, you will have hydrogen. Okay, but after neon, you will have what? It will be what? Lithium, beryllium, boron. ना? तो lithium हो जाएगा यहाँ. Lithium, then beryllium, then boron, then carbon, then nitrogen, then oxygen, and then fluorine. ऐसे जाएगा, ठीक है ना? This will be the trend. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
ये देखिए जरा. Plot you have, right? So you have lithium, then beryllium. See, largest atom is lithium, right? I mean, if you leave the neon, then lithium, beryllium, boron. See here. Lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then neon will be the largest because आपको इसी तरह याद रखना because उसके वैन डर वाल रेडियस आता है ना. ठीक, अगर आपसे सवाल आ जाए कि why is the noble gas having the largest size, then you will say because we are having van der Waal radius for that. Okay. In that, if we are measuring the van der Waal radius, okay. So if you want to compare the noble gases, right, next point. For comparison with noble gas, the van der Waal radius of other elements are taken. For better comparison कर सकते हैं आप. For better comparison with the noble gas, the van der Waal radius of other elements are taken. All of you understood this recently? Now, we are writing? We are writing notes or something like that. Write one more note here. If you look at the 3D series, and if you remember the D block elements, we have 3D series there. So the atomic radius of 3D series, it follows this order. Please write atomic radius of 3D series. So these are Sakti, Vikram, and Fekon equation. So the Scandinavian will be having largest T, V, Kra, and Man. Sakti, Vikraman, like this. Okay. Then Fekoni will be having similar. Iron, cobalt, nickel will be having similar. If I compare copper and zinc, then in that case, zinc will be having larger size. ठीक है? ये तीनों चीज आपको याद रखना है. Sakti Vikraman, Sakti Vikraman. Fekoni same. Then fusion में zinc is going to have larger. Is everyone done? Yes or no? Please tell me.
Yes, sir.
एक और ग्राफ है जो कि that is going to be very crucial here. इसको भी जरा आप लोग देखते चलिए. ठीक है. So yeah, if you look at this particular graph here, see we have lithium and fluorine. Lithium and fluorine. Both of these are where? Both of these are in group 1. Sorry, not group 1, my bad. Both of these are in period 2. Second period, right? So lithium is having so large, right? 152 picometer. And fluorine is having how much? Fluorine is having 72 picometer, right? So as you can see, if I go from lithium to fluorine, then what's going to happen? Along a period, the size is going to decrease, right? Sodium to chlorine, third period. Potassium to bromine, which period this is? This is fourth period. Then we have fifth period, right?